Hello, welcome everyone to this webinar um, set of webinars around Arduino Pro and some of applications. Hi, Patrick, how are you doing?
Hey, I'm good. How are you, Nick?
Everything's good, everything's good. Well, so let's get started. I'm gonna share the screen.
All right.
Ready.
Okay.
I'll let you start with it.
Yeah. So, again, welcome to this webinar series talking about how Arduino Pro and DeepSea Developments can help make your development efforts better, faster, more productive. Today, we're going to be talking a little bit about EV chargers and how innovation around EV chargers can be accelerated with some of the different products and services inside of this chat. So today we're going to be talking a little bit about just the industry overview. First we'll start talking, introduce ourselves a little bit. Then we'll talk a little bit about the EV charging industry as a whole, kind of set up why this is an important space to be developing in, what are some of the possible opportunities there. Then we'll talk a little bit about Arduino Pro, how they differ from the standard Arduino ecosystem. And then we'll talk a little bit about a couple of different use cases just to kind of get your imagination going and get your creativity flowing. And then finish up with a little bit about Arduino Pro and some of the additional things that they offer, and how DeepSea can help accelerate those efforts as well. Right. So first, a little bit about ourselves. My name is Patrick Lloyd. So I'm an engineer for DeepSea Developments, and I'm a hardware and firmware guy. A little bit about myself. So I live in the Bay Area now, but when I was a wee lad, I lived in Egypt as a baby. My dad was in the Navy, and so we lived over there. Nick, could you introduce a little bit about yourself?
Sure. Well, I'm Nick Velasquez. I'm the founder and CEO of DeepSea Developments. I'm very passionate about product development. That's what was the main force to create the company. I consider myself a maker. So as Patrick, I am an electronic engineer. So strengths, hardware, firmware, but then very eager about other things like 3D printing, mechanical things, robots. And yes, as a fun fact, I can almost solve a Rubik's Cube under a minute. I can solve it, but not under a minute yet. I'm close. But yeah, getting there.
All right. So let's talk a little bit about EV charging as a whole, why you want to do it, or I guess why it's important, and what are some of the aspects of it that are interesting. So first of all, DeepSea has a lot of experience around EV charging. They've built several different solutions around that, and so it's something that we have domain expertise in, and a good bit of technical and business insight into how it works. It is old enough that there are ecosystems around it. There's open source products, hardware and software, that are existing to try to help standardize the space. And there's ways that you can adopt those in order to accelerate development. So you're not, reinventing the wheel starting from scratch, so to speak. However, it is a reasonably young industry, and so there's a lot of opportunities around new and existing and emerging technologies that make innovation opportunities readily available. So, for example, everything's been invented, right? You can go on Amazon right now and you can find several different variants of home chargers. These are things that run off 120 volts, things that run off 240. There's also there's also other options for doing like DC to DC conversion. And we'll talk about that a little bit more later, but this shows that there's existing resources and existing players in this space that are already creating like the base systems of like providing the charging circuitry from your electrical outlet to your electric car. However, charging is a solved problem, but there's a lot of value add that can be put on top of the charging that has not been solved, and so there's a lot of room for innovation around there. So a little bit about what the different types of chargers are. So like I mentioned, there's level 1, level 2, and level 3. Level 1 and level 2 are AC chargers, and so those are the kind that you'd find off of Amazon, ones that are going to connect into your home AC wiring. And then level 3 is more for DC quick charging. So you'll find that at like a Tesla supercharger station, for example. All right. And Nick, would you like to talk a little bit about the industry as a whole and kind of set up for why this is an important space?
Yep. Give me a moment. Yes. So in terms of the industry overview, we see that EV charging is something, or electric vehicles in general, is something that it's growing and growing, and is expected to be $363 billion industry by 2034. There are some main drivers for the growth of it, that needs to be set in place in order for this to happen. There's the rising need of fast EV charging networks, basically being able to go cross country without the fear of getting out of charge and without the inconvenience of having to wait long time to charge, that it's able with level 1 and 2 or portable chargers, but those take a lot of time. So the level 3 chargers, DC chargers, are the ones needed for those long trips. Also, there's the need to convenience when charging. You can have a network of chargers around you, but if you're living like in a multi family condo or something like that, if you're not able to charge at your own home, that's an inconvenience. So there's the need of having better ways and more convenient ways to charge. At some moment, I think right now when we talk about combustion engines, like regular vehicles, you say, like, in the comparison, you have your normal car, you're running out of gas, then there's a gas station near you, and it takes, what, 5 minutes at most to charge, to put gas, and that's it. So that's very convenient. I think that there will be a future where we'll say, like, that's crazy, you have to go somewhere to recharge your car, where I can do it while I'm home, so I don't have the inconvenience of going elsewhere. And sure, if I'm doing a long trip, then I have the network of fast chargers to do it fairly fast. So I think that that's something that it's needed, and there's new government mandates all over the world towards reducing emissions. So that's something important to have in mind. And there are some challenges in general, high cost of installation, product cost, but others that relate to the ones that I mentioned before, is how to improve that experience for people to see electric vehicles as a better option than the regular combustion engine vehicles. I also wanted to talk a little bit about the ecosystem. Some elements of the ecosystem that are very important in terms of developing or innovating around what already exists. I think the most important is the OCPP protocol, the Open Charge Point Protocol. That's basically the way chargers connect to systems. And so, for example, if you have a network chargers and you wanted to connect to an app to pay for that, you don't have to do custom protocols or something like that. That's an open source protocol that makes things easier for all that communication. And that's a standard right now. That's the good thing. So if you're going to buy a charger that has connectivity, it should have OCPP integrated. The other element is also open source. It's called Open EVSE. It's a project of doing electric vehicle chargers, the electronics and the whole package, open source, and it's based on Arduino. So you have the possibility of going there, modify, understand. It's a good tool to have around. And there's other elements that are also open source, a little bit more sophisticated. So if you want to do more sophisticated charger, maybe a level 3 or have a little bit more complexity, then you can use a project like EV Everest that it's backed by the Linux Foundation. Basically, it's a stack for Linux in order to have all the basis for the EV charging. Then you put the innovation on top of that, but you don't have to worry about the basic. As we mentioned before, there are things like the chart itself, it's already invented. You could innovate in that, but we see that there's a big opportunity to innovate on top of that. So these tools make things easier in order to build on top of what's already there. These are a little overview of photos of what you can get with OpenEVSE. You have the version that it's the whole charger and the electronics that are inside, and they have different modules and things for doing with internet, without internet, etc., etc. So it's very flexible. And this is around OCPP, a little bit to show that these are all the brands that are behind the establishment of that open source protocol. So it assures that it's going to be compatible because they are backed by big companies. So it's an interesting thing to know. Now, talking more about what we're going to talk today is that in the EV charging industry, we see a couple of opportunities. It's like a couple of ideas that can be built on top of what's being made. So for example, entertainment while charging. Some of the chargers level 2 that are available, you have to wait 3-5 hours in order to charge 100%. So normally the chargers are in next to restaurants, next to malls or inside malls. So you are doing something meanwhile, but there could be an opportunity to do something more in the charger itself. It's just a thought. Security while charging. You want to make sure that the charger is secure, and you want to make sure that the vehicle that is charging is secure. And if something happened, then have an alarm or something like that. There is a lot of cases of chargers that are left like in rural areas or different parts, and people stole the hoses for the copper that is on that. So having that kind of security, it's a good feature to build on top of the charger itself. Or for example, you have a network of devices that have electricity, so you can take advantage of that and have a network of something else on top of it. For example, a network of quality air sensors, so you can also measure what's the quality air around those chargers. That could be a very interesting and very useful applications for different cities or counties in order to track what's going on with the air quality of general zones in their place. And here are some examples of commercial. These are startups. They are already in the market of companies that did things around the charging itself. So, for example, Volta, what they did was getting the chargers to be also screened for advertisement. So they could have also all the ad that moves billions of dollars annually tapped into the experience of charging. So that's one of the examples. And for example, this other one, Voltpost, the interesting thing that they are doing is that they want to connect to existing light they want to connect to existing light like street lights in order to make it wider available charging without having to build further infrastructure, like all the construction around building a public charging station. So that's an innovation that it's around the charging itself, that it's very, very interesting. Okay, so next, let's now talk a little bit about Arduino Pro. From all these years, we've know Arduino as a brand that have approached people that are not technical into doing some very, very cool things. At the beginning, were art students, art people that were able to light their first LED in order to do designs and things that were before very strange to them. So it was an easy way to get into the electronics. With the time, it turned into the easiest way to get into design product development around electronics. And it's it's an example of how to get a lot of people into building things, very used in maker communities. But then people start also using it in their products. So they start launching things, and Arduino saw the opportunity of building another version of robust. Arduino saw the opportunity to launch a version for the industry, and that's what Arduino Pro is. Leveraging all the things in the community, like the components, the libraries, everything that was supported by the great community that has Arduino, but now having the capabilities of using that into industrial applications and being robust, reliable. So that's a very, very interesting approach of it. So we're going to talk a little bit around the line of products that they have. So this is the Portenta line of boards, and basically they have a variety of boards from H7 to X8 to C33, giving a balance between power and power consumption, and also cost-effective solutions. So there's possibilities regarding what's going to be the application in and how power hungry it's going to be, how many processing do you need. So it's an interesting variety of modules. Then there's the nickel line, where you have something that is smaller, so it works for not only prototyping some wearable devices, but there are applications with the size and all the shape allows it to be on a commercial product. And the variants of the board goes from nickel vision, that it's mainly for capturing all the camera, being able to run algorithm detection algorithms inside the board, to something like nickel sense that has a variety of sensors and are able to do the processing, or something more specific to voice, like the nickel voice for trigger detections, like you will use Hey Google or Alexa. You can program things like that in these boards. They also have the Optoline, trying to get into more of the industrial automation world. So normally you will use PLC. This is an PLC made by Arduino, with also additional tools, so it's easier to program if you come with a background of industrial automation. That's a very interesting line, and they have, as well as the other, a set of lines and expander modules for more inputs and outputs, or different types of connectivity and yeah, in general terms, protocols. And this all comes with a line of accessories to be able to have your portenta boards and being able to put them, testing, and even deploy solutions with this in mind. So that's a quick overview of everything regarding the Arduino Pro line of products. In general terms, what you could say there are the trade-offs with or using Arduino Pro. You normally do things faster because you leverage the community, you leverage all the code, you leverage all these sensors. So for example, if there's a specific sensor that works with Arduino, then you can also use it with Arduino Pro. And also Arduino Pro are making these for industrial applications. So there's enterprise support in order to make sure that it's gonna work for the intended purpose. What happens when you don't use Arduino Pro but do regular development? Normally, with that approach, you could get lower costs in terms of mass production, because you are designing it very custom to your needs. But the trade-off is that it's gonna cost, it's gonna have a higher cost of development and iterations in order to get to a point of deployment to the field. So there are trade-offs, but in general terms, not only we think we have used Arduino before, and that has made the speed of going to the market, the times for going to the market very, very, very low.
Great. Yeah, I think that there's a lot of cool opportunities around using Arduino Pro and that hardware to basically test out ideas faster. And once those ideas are proofed out and you have, working code, Arduino Pro also has the supply chain infrastructure that you can go into, like small and medium runs of that, like using that hardware in actual products, which is pretty cool stuff. And so,
and I will also add to that at the end, the objective, and I think that we're going to talk about that a little bit later, but Arduino Pro, and in general Arduino, it's something that allows people from different backgrounds to get into development. So you don't need to be hardware and firmware developer in order to get started. If you have an idea, then you could start prototyping with Arduino Pro, and be able to iterate, have those first iterations, and getting to see what your product would look like. That it's something very, very powerful that, I don't know, like 10, 15 years ago was very difficult. So yeah.
Yeah. And so just as a couple different examples of how you can innovate on top of EV chargers using some of these different prototyping platforms, we came up with a couple of different ideas. And one of them we were discussing previously around like AI security. Having some sort of way to monitor not only the charger but also the vehicles around it is it's an area with a lot of excitement and opportunity. And one of the challenges around that, though, is being able to perform this AI at the edge, potentially in situations where wireless networks can be spotty. And one of the interesting aspects of Arduino Pro is this NICLA series. So this NICLA vision board, it has a bunch of sensors on it, in addition to a camera, a depth sensor. It has a microphone on it, and a few other sensors that can all be processed on the device itself. And so this would allow you to do, edge AI, object detection, event recognition, looking for, thresholding, and if like, a window breaks or something like that, that could trigger a condition inside of the device itself. And so you can do a lot of very interesting and sophisticated AI processing on this device itself. And then that can also help you provide authorization to the charger. So, if you have like a QR code on your phone or something that, is required to turn on the charging features, so you don't have unauthorized use of these chargers, that's another way that this vision system can be used to protect and enforce certain policies that you deploy for your charger. It also has a Wi-Fi modem on it, and so it can connect back to the internet and can provide events to the cloud. Arduino Pro also has a cloud infrastructure that can monitor the sensors, that can provide additional analysis opportunities, and can even you can help visualize the data coming out of these devices, and can all be stitched together into a large scale solution. And looking at just sort of a general cost overview of this solution. So like the fully assembled open EVSE is about $580. The Arduino Pro NICLA Vision, $115. And then there's going to be, naturally some additional miscellaneous components, cables, batteries, cloud, probably set you back about $100, in total. And so for under $800, you can start developing this robust AI solution for charging infrastructure, which is pretty interesting. Sorry, go ahead.
Yeah, if you can go back to the architecture, one of the things that I will also say is that, for example, if you're a software developer, then doing image processing in the cloud, it's something very straightforward. It's something that there's a lot of tools in order to do that. It's going to be super easy. But then if you're thinking about a new startup idea, a new project idea within your company, where you have to deploy thousands of these units, then if let's say that everyone has direct connection to the internet, but then the operational cost of having every or set of image processed in the cloud, it's gonna be huge. Here, you're gonna have something that it's gonna be processing only what it's needed, and maybe just send a couple of bytes of data saying everything is good, there's a flag. Maybe you don't even have to stream any image to the cloud, or just the photos or the videos of the events that happen. But that, in terms of operational cost, it's very important, especially if you're getting into volume. So yeah, I would say that this is a very important feature of doing edge computing AI on the device rather than leaving everything to the cloud.
Yeah, and excuse me. Yeah, I think that cost is especially important in consumer electronics and consumer applications. Another area where having on device or local edge compute is if you are deploying, say, an EV charger in a home. So NEMA in the US is a standards organization for dealing with electrical infrastructure, and they define like the plug types and all that kind of stuff. But they recently provided some additional guidance on EV to grid power systems. And so one of the areas that is especially interesting for electric vehicles and like the future of electrification overall is this idea of a smart grid. And so as more people are installing solar panels on their homes and battery systems like the Tesla Powerwall inside their house, using your electric vehicle as a supplement to that is an area with a lot of potential and a lot of opportunity, but not a lot of wide-scale deployment yet. And so having something that can, a system that can make sure that your vehicle is charged, but also in times when, maybe you have a power outage, your vehicle can help serve as a battery backup for your home. But also, like, for example, electricity prices can fluctuate throughout the day, and having your EV plugged into your home can help you save money by not using the grid power during peak hours, and making sure that you can regulate your grid power consumption versus overall power consumption in a way that helps you save money. And so a way that can be implemented, so using the EVSE, Open EVSE, just the bare board, that can be integrated with maybe like a home inverter system or a Powerwall, existing DC infrastructure, and then using the Portenta series. It's a very capable Linux computer, and so that can provide a lot of the analysis and AI and projection capabilities integrated with this carrier board that you can get. And this carrier board can provide the relays and the actual like electrical connections between the car and the home, as well as sensors, as well as wireless capabilities. And so having all of these capabilities on device allows you to perform these tasks without having to perform all of these functions in the cloud. So if a Wi-Fi network goes down, for example, it's still able to function. It's still able to perform its stated features on device. And once Wi-Fi and the network is restored, it can provide all of that information as telemetry back to some sort of reporting service. And looking at that, again, for less than $800, using the Proto Kit, which has all the sensors on it, is going to be about $400. The Portenta H7 is a lower power controller that is going to set you back about 115. The Open EVSE, just the bare charger alone, is 130. And then your additional, cables, relays, cloud connectivity, all that kind of stuff has some miscellaneous cost. But yeah, overall, it's still, less than $800 able to start prototyping with this kind of stuff. Another kind of bit of a wacky idea here, but potentially pretty interesting. There's a long-range radio protocol called LoRa, stands for long range, and it has a low bandwidth but high transmission range. So you can send text messages basically over several kilometers. As it's in a point-to-point sort of way. And one idea here is that if you say you're driving in an off-grid environment, right? You don't have cell coverage, you don't have Wi-Fi, and your electric vehicle runs out of batteries. Having some sort of system where you can radio for help, and then somebody else with a compatible EV can receive your messages over LoRa. They can come drive out to where you are, and using a device based on Open EVSE, you can have them basically charge your vehicle with just enough power to get you to a charging station, basically as an emergency charge sharing device. And so using that uses a couple of off-the-shelf components here. So this uses the more high performance Portenta X8, which is the Linux carrier, the Linux based single board computer. Using the Open EVSE still, and then a carrier board for it, just so you can break out the additional signals. And the only additional thing on here is it's an Adafruit LoRa transceiver you can get for about $20. So again, this is an even less expensive solution here for less than $600. And one of the final just ideas is talking about like a network constrained system. So say you're in a basement parking garage or something like that. There's no network available. It's cost prohibitive, or just you're unable to provide wired or like wired networking, or any sort of there's no existing like Wi-Fi networks. So being able to manage several EV chargers, look at the telemetry from them, aggregate all of the data, you can do that with LoRa again, which is this long-range protocol. But you can create a mesh network that allows these different EV chargers to communicate with each other, and then eventually get that information back to a gateway that has network connectivity, either with Ethernet, cellular network, or Wi-Fi, and then is able to communicate using that open charge point protocol back to the server. And so just as a quick aside, using the Portenta boards, the X8 or the H7, they're very capable boards, but they don't have a lot of additional hardware. Most of the actual like I/O is broken out to these like high density connectors on the bottom side. And so when you get one of these carrier boards, this breaks out all of those connections, and Arduino provides these really sophisticated carrier systems that have connectors for wireless antennas and for SIM cards. It has areas for like putting a battery in there, connections for mini PCIe, so you can put a an additional Wi-Fi card in there. It has Ethernet connectors, USB ports, all sorts of different things. It has CAN, serial, etc. And so all of those things are a way that you can provide a ton of additional networking and sensor capabilities without having to design any additional hardware yourself. And so that is a very powerful add-on accessory.
One thing that I will say in this example that I like a lot, it gives you the flexibility in the use cases. So yeah, as we mentioned, and we've seen that happening. So you could say, yes, if you don't have the possibility of doing wired Ethernet, then you can put your own Wi-Fi network. But there are places where technically it's possible. Sure, you can put a router, but because of the internal policies of the place or things like that, it's very inconvenient. So things like having LoRa allows you to having the wide range, and then you could put your gateway, the Portenta with the carrier board, the Max carrier with the H7, for example, in a place where you can wire it directly with Ethernet. Problem solved. But that's still a problem, then you can have a place where it's Wi-Fi. But if that's a problem, then you can have cellular network, and that will not be a problem because then you'll have connectivity directly to your cloud. So it gives you the possibility of thinking about several use cases. So if you're gonna prototype this or install this in several locations, it can adapt to the situation without having to add more things in the hardware, which makes it very, very convenient in general terms. Yep.
Cool. Yeah. So we can take this opportunity now just to discuss a little bit about Arduino Pro and just why it is why it makes sense from a development standpoint. Is that it allows you to really take an idea and start running with it very quickly with really low development costs. And so you can leverage the existing set of Arduino sketches that are already out there, the libraries, the general community, and you can start building that into a legitimate product. And using this hardware that is, it's not gonna, evaporate on you once you try to scale. And one of the things that we can discuss is that, like, once you have this product, once you have this prototype that is it's in the field, you're testing it. A great next step is with DeepSea Developments taking these different prototyping boards and bringing them together into a refined product. Doing additional cost savings, doing additional supply chain optimizations, and integration into a smaller package is something that is a very logical next step for a product like this.
One of the things that I would say also is that, as I mentioned before, Arduino has made electronics easier for everyone. So we in DeepSea Developments, we are able to do custom product design, but we want that if you have an idea for either it's an idea that you want to make a product or startup with, or you're in a company and you want to prototype something within your company. For example, you have software backgrounds, or you're able to code a little bit, then you should be able to get the first steps into getting a fast prototype. And that's the powerful thing about Arduino and Arduino Pro. One of the things that I usually hear from people is that when you think about Arduino, you think about doing, it's mostly in the maker community, so normally the costs are low. So when you see prices for the Pro line, then you can say, okay, this is not in my range if you are a maker. But Arduino Pro, it's for going to production. So that is the reliability, and that's will be like the hidden cost if you start with something very cheap at the beginning that it's not necessarily ready. Then you have to go to many steps in order to make it production ready or market ready, and that will be the trade-offs of the cost in terms of the unit cost, the development cost, certification costs. That's something that it's really important. If you're trying to get a product out of the market and want to sell it, then you could go to certifications like FCC and things like that. If you are using elements that are pre-certified, like the line of Arduino, you're adding a couple of things, then sure, you have to do FCC certification, but it's going to be much easier, faster, and less expensive than doing the whole certification from scratch. And what would you say, Patrick? You were mentioning about the capabilities of DeepSea, but when do you think it's a good moment to go from what you already have, like getting the max carrier board and things on top, and start engaging with DeepSea, for example?
Yeah, so DeepSea is it's able to help at any of these stages of product development. Be it a napkin sketch all the way to getting ready to go into full scale, large scale production. But when using these sorts of Arduino Pro prototypes, we would generally refer to that, kind of in like a phase 1 or phase 2 of product development, where you have an idea, but like once this idea is being used, or like there's you're starting to get customer engagement, you're starting to see this emerging business case of like, all right, people actually want to use this. We have a couple units that are like deployed in the field and actually being utilized by individuals. That's a really good time to start engaging with somebody like DeepSea Developments, where we can take that and help you as you're scaling, as you're growing, to be able to move faster and take these units, and as you're starting to deploy more and more, decrease the unit cost of them as the volumes increase. That's just as you start to go up that, like the revenue returns, your per unit cost should start going down, and so you want to engage around there to help with that crossover point.
Yeah, makes totally sense. And also going back a little bit, for example, with this example, in terms of the gateway, like this part over here, as you have everything that you need in a single board, that could be good enough for going to the market. You have the connector, you have the things. So it's good to go. But then for specific applications, you might need that specific sensor or a couple of sensors. And in the prototype phase, what you're gonna start doing is connecting to these connectors, cables to the other like daughter boards or shields, and start having like spaghetti monster with all the additional boards. And that's okay. That's part of the prototyping. That's something that even in a professional level you do at the beginning in the prototyping. You don't skip to have the perfect board. You do the cable connectors, the spaghetti phase, at least for a while you're validating. And then when you want it to be reliable, the reliability could be lost by just having that connector, because some movement, janking a cable can make that your application fail. So that's also something of building custom shield boards or doing redesign of boards will make everything more robust as having everything into one board. So yeah, that was an additional example that I wanted to make of possibilities. And finally, I'll say that the invitation, as mentioned, it's to start working and to start going from idea to hands-on. Arduino Pro makes that things possible. Today we talk about EV charging just as an example, but this can be used in many industries, and that these are just a couple of examples of things that you can do in this specific industry. The idea is that in the series of webinars that we're going to have, we're going to talk about other applications, other approaches in terms of how Arduino make things easier to get from idea to market. I don't know, Patrick, if you want to add anything else to the space?
I think I think that this is an exciting space. I'm looking forward to seeing the kinds of projects that people put together leveraging these tools. I know that Arduino provides a lot of capabilities here and a lot of possibilities for innovation, and so especially paired with this EV charging space, I think there's going to be a lot of really cool stuff coming out in the future.
Awesome. Thank you very much, Patrick.
All right. Thanks, Nick.
Thank you very much for everyone to connect. Have a good one.
All right. Take care.